The contents of the sidebar created when a curve is selected changes between object mode and edit mode. In edit mode, the Bezier curve has different set of fields than those shown for the NURBS curve. Starting with a Bezier curve in object mode, the sidebar's item page contains location, which allows us to move the curve along with its origin. Rotation determines its rotation about the three global axes, and the field below allows us to select the order in which the rotations are applied. Scale can be used to adjust the curve's shape in the x and y directions. Alternatively, when we want to specify the actual dimensions of the curve, we can set the x and y value in dimensions. Although changes in the z direction have no effect on the basic curve, if we've previously used the extrude option in the curve's data page in the Properties editor, either of these two fields can be used to adjust the size of the extrusion. Once we change to edit mode, the sidebar's page changes. The first three fields, which are headed median if more than one control point is selected, and control point, if only one control point is selected, control the position of the selected elements. Moving on, and assuming only one control point is selected. Below the x, y, and z values are the selection options global and local. When global is selected, the values in x, y, and z represent world coordinates. When local is selected, x, y, and z give the distance from the curve's origin. The weight value is used in conjunction with physics simulation, a topic for future videos. Radius affects the local thickness when we've used depth or extrude. Tilt adds a twisting effect between the currently selected control point and those on either side, which is most obvious when used in combination with extrude. We can also activate a mouse-controlled tilt by pressing Ctrl-T and reset the tilt by pressing Alt-T. Under the Active Spline heading, Cyclic will join the two ends of the curve to create an enclosed space. Resolution U is the same as Resolution Preview U in the data page, giving the number of curve calculations between each control point. Changing the value in the data page also changes the value here in the sidebar, but strangely, the reverse is not true. Interpolation tilt sets the algorithm employed when a tilt value is used. Linear creates a twist that is uniform through the whole rotation. Use this option for corkscrew or spiral effects. Ease creates the maximum twisting effect at the center point between the control points. There is no clear documentation for the last two options, cardinal and B-spline, so it's just a matter of try them and see if you like the result. Interpolation radius gives the same four options as the previous field, using different algorithms to determine how the radius of the curve is distributed between control points. Again, it's a matter of try it and see what suits. The Smooth checkbox, when selected, implements smooth shading on the surface of the curve. When we select a NURBS curve, although object mode's sidebar is identical to that created by a Bezier curve, when we change to edit mode, there are a few differences. Under control point, as well as the usual x, y, and z, we have an additional field labeled W. This assigns what is often referred to as a weight factor. But since we also have a field labeled weight, this is a rather confusing term to use. So let's call it an attraction value. The larger the value here, the more the local part of the curve moves towards that control point. Weight, radius, and tilt were discussed in the earlier part of the video with the Bezier curve. Under the Active Spline heading, Cyclic joins the two ends. Checking Bezier changes the maths used in calculating the curve to match that of a Bezier curve. However, the default NURBS curve may disappear completely when we check this option. This is because we lack enough control points, but using subdivide solves this problem. Notice that one effect of this checkbox option is that the start and end points of the curve fall exactly on control points. End points, when checked, forces the ends of the curve to position over the end control points.